Hi guys, welcome to a new IMONST video. So in this video, we'll be talking about last year's IMONST, juniors problem 6 to 9 and seniors problem 1 to 4. Now, so for this problem, let's look at problem 6. Find the value of plus 1, plus 2, plus 3, minus 4, minus 5, minus 6, plus 7, plus 8, plus 9, until negative 2020, where the sign alternates between plus and minus after every 3 numbers. Now, since we know that the signs alternate after every 3 numbers, so that we can make like a 6 numbers per period thing. So let's just examine plus 1, plus 2, plus 3, minus 1, minus 1, minus 6 first. So we have plus 1, plus 2, plus 3, minus 4, minus 5, minus 6. And then we see that 1 and plus 1 and minus 4 give us a negative 3, and then plus 2 minus 5 give us also a negative 3, plus 3 minus 6 give us a negative 3. So these 6 numbers will give us a negative 9. And then now let's look at 7, 8, 9, 10, 11, 12. Okay, so 7, 8, 9, minus 10, minus 11, minus 12. As you can see, this one also gives us negative 3, negative 3, negative 3. So this is also a negative 9. So from here we can conclude that every 6 numbers gives negative 9. So we need to see prior to 2020 how many cycles of 6 are there, right? So we would have 2020, we just divide by 6, we would have 336. I counted this before, so don't follow. Then we have 4 numbers left. So we have 336 periods of giving us negative 9. But that's not the last thing. We also have 2017, 2018, 2019, and 2020. So these 3 are positive, and then this one would be negative because of the alternating signs. So we're just adding these up, okay? This is a simple addition problem. You just need to do some addition. So negative 336 times negative 9 is negative 3024, and then we can make the positive 2019 and 2020 become a negative 1. So now what we have left is just 2017 plus 2018 minus 1, and then minus our 3024 in front, right? So we have 4035 minus 3025, which will give us 1010. This is the answer to problem 6. Of course, there's another way of doing it, but I'm not just covering it. You can give your solutions down below in the comments. But now let's move on to problem 7. Natalie cuts a round pizza with 4 straight cuts. What is the maximum number of pieces that she can get? Then assume all the cuts are vertical. So let's just imagine a 2D circle, right? Okay, I'll draw one. Not really draw, just take one. Something like this. So with 1 cut, obviously we can turn 1 piece into 2. But with 2 cuts, how many could I turn it into? So I could turn it into this, then this would become 3, which is not the maximum. The maximum, it happens when you make this cut cross the first cut. So we have something like this. So we have 4 pieces right now. And then after having produced 4 pieces, how many can we produce with the third cut? So again, we could do something like this, but this is just giving us 1 extra piece, which is not really useful. And this one, what gives us 6 pieces, but is also not really useful. So we see that if we let the third cut pass through the first and second cut, what will we get? We will get 1, 2, 3, 4, 5, 6, 7 pieces. So to maximize the number of pieces that one can get, we need the newest cut to run through all the previous cuts, right? So we have 7 pieces right now. And then now we just move. So using this using this observation, we want to let our 4th cut run through the first, second, and third cuts. So what we'll do is do something like this. So we just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we will have 10 cuts. And then as a generalization, so for every n cuts, the maximum happens when newest cut newest cut intersects all previous cuts. And then the number of pieces, then the max number of pieces will be n times n plus 1 divided by 2. Now, how did this come to be? You can figure it out for yourself. If you are interested in telling me the answer for this, how did this come to be? Of course, you can put it down in the comments, okay? So this is just a formula. Now, let's move on to problem 8. So, given a circle with area A, and then, so let's draw a circle like this. No, square. Square with area A. Then a circle lies inside the square such that the circle touches all sides of the square. So we need to put a nice circle here, something like this. And then another square with area B lies inside the circle such that all its vertices lie on the circle. So we would have something like this. No, move up a little bit. Then we could have something like this. I know it's not the most accurate photo, but yeah, something like this, okay? So this square outside, so where's the pen? This square outside has area A, then this square has area B, right? So that it touches, so that all its vertices lie on the circle. So find the value of A over B. Now this is very easy. Why do I say so? Because if you can rotate the square inside, right? You can rotate the square, but I can't rotate using this picture, so I'm gonna use another picture. Something like this. Okay, so you can rotate the square and turn it into something like this. Okay, something like this. Then we maximize it, then we enlarge it by a little bit. As you can see, we now have a square. It's like this. Then the square, when after rotation, it will look something like this, right? Then coincidentally, it touches all the midpoints of the largest square. So what we can do is just cut it into half. So this one equals to this one. This one equals to this. This one equals to this one. This one equals to this one. This one equals to this one. So we can see that the smaller square is exactly half of the larger square. So as we can see here, we would have the smaller square if the smaller square's area is 1. Then we will have the larger square having an area of 2 because all of the pieces as we see cut here are double, right? So large square would have area of 2. So just A over B is just 2 over 1, which is 2. So this is the answer to problem 8. Okay? If you have any difficulties in understanding any problem solving process, you could write it down in the comments below. Now, for the last question of this video, sequence lists the perfect squares in increasing order. 0, 1, 4, 9, 16, all the way to A, and then 10 to the power of 8, and then B. So we need to determine the value of B minus A. Okay? Now, we know that 10 to the power of 8 is some square, but what is it? So we just put it into a root, right? Into a root. So 10 to the power of 8, we will have x equals 10 to the power of 8 equals to some x squared. So our x will be equal to 10 to the power of, we can just say 8 times 1/2 would be 4. So x equals to 10 to the power of 4. So as we can see here, we will have A, 10 to the power of 4 squared, and then B. So we know that A equals to 10 to the power of 4 minus 1 squared. Then this is 10 to the power of 8 itself, and then this would be 10 to the power of 4 plus 1 squared, right? So if you want B minus A is just this thing, 10 to the power of 4 plus 1 squared, minus 10 to the power of 4 minus 1 squared. We would have 10,001 plus 9999. Okay, and then we have 10,001 minus 9999. So what we would have is 20,000, 20k, and then times 2 would give us 40,000. So this is the answer. This is a direct computation, so we do not fret much. Okay, so this brings us to the end of the video. So I hope you guys like this thing. I don't know. If you do, just press thumbs up. If you don't, just press dislike. To each their own. So in the next video, we'll be discussing problems 10 to 13 for juniors, and then for seniors, it'll be problems 5 to 8. Okay, so see you next time. Ciao, ciao.